Test for parallelograms. Okay, what do you do when you test for something? Yeah, to find a result, see if something happens. When you go to the doctor and you've got a sore throat, what do? Test for what?
Strep.
See if you got strep. The test is them sticking a swab, about making you gag, touching the back of your throat, and then putting it in a culture and seeing if you have strep. Okay, that's a test to see if something is something. Well, tests for parallelograms, they're tests to see if something is a parallelogram. So that's what we're going to do today. We're going to give you some tests to say, okay, I can say that's a parallelogram. Okay? We're going to have a bunch of tests right here. The first test. Are the opposite sides parallel? If that is the case, then what are they? What is it? It's a parallelogram. Are the opposite sides congruent? If the answer is yes, then what is it? It's a parallelogram. What do you think the next one's going to be? Are the opposite, what's left? Angles congruent. If so, then what? It's a parallelogram. Does this look familiar? Anybody? Huh?
Looks like what I did yesterday. Another one I had one.
I heard somebody say something about last section. Did I hear that? The last what? Yeah, it looks a lot like that, doesn't it? These tests look like our rules to see if something is what? A parallelogram. And guess what? For the most part, that's exactly what they are. Your tests are those things. Here, though, is a new test. Or I'm going to say not are, I'm going to say is, sorry, is one set of opposite sides, both congruent and parallel. This is a new test, or something that we didn't talk about yesterday. It's really more for just testing whether something's going to be a parallelogram or not. So what am I saying here? It's important that we can read this and understand what it's saying to us. I'm saying is one set of opposite sides both congruent and what? Each other time I was talking about two sets, either two sets of sides being parallel, two sets of sides being what? Congruent, two sets of opposite angles being what? Congruent. So, what do you think? What does this mean? Just one set of opposite sides being both what? Congruent and what? Parallel. So that's what that would look like. Either this set, or you could, but you don't have to know anything about this set. Make sense? See why that's different? It's just one set. But it is also two things about that one set. So it seems like there's always two things we got to have to know. We can say that's a parallelogram. Now, this is the new part, but guess what? All those things that we talked about yesterday also work as tests. What else was there? Are the consecutive angles supplementary? What am I saying there? These two add to 180, add to 180, or this one's add to 180, or these add to what? 180. What's another test? What was, somebody look at yesterday's assignment, or notes. What else did we say? Let's see, there were 6 things, right? So we ought to have 7 things here because we added a test, didn't we? We're on 6, that means there's 2 things we're missing.
Diagonals bisect each other.
So I could say do the what? Diagonals bisect each other. What would that look like? Just a quick sketch. Right? What would the last one be? So I could say, does one diagonal make 2 congruent triangles? If any of these happen, then guess what do you have? You have yourself a parallelogram. So in essence, this section is just rehashing what we've already talked about, isn't it? But doing it from a different angle. Instead of saying that's a parallelogram and you have to know that all this happens, now you have to say, is that a parallelogram? And you look and see if any of these things happen. If any one of these happen, then you can, what's the answer to that question? Yes, it's a parallelogram. If you can't find any of these that happen, then no, you can't say it's a parallelogram. That picture may very well be a parallelogram, but with the information given to you, you don't know for sure. You know for sure if any of these happen. That's the difference between this section and the last section. Best way to learn about this material is through practice. That's how we study for tests. That's how we learn material, is through practice. Hence why, in my opinion, why I make homework worth so much in my class. You learn about this stuff through practice. That's what the homework is. So that's what we're going to do in our notes. Let's look at page 75. Determine whether each quadrilateral is a parallelogram. Justify your answer. That is a very important part of this assignment. When it tells you to justify your answer, if I just see yes or no, then you've only done half the problem. And truthfully, you've done the easiest part of the problem, the part where you could just simply guess what? Yes or no. So how much do I know whether you're engaging in the material and practicing and trying to understand? If you ask a question, then I know you're trying. So come up and ask a question if you don't know how to justify your answer. That's why we're here. Now, here's how we're going to do some examples, and I'll show you how. Determine whether each quadrilateral is a parallelogram. Number 1, can we say that's a parallelogram? Why?
One pair of sides is congruent income.
So one pair of opposite sides are congruent and parallel. That wasn't so hard. You know what you've done right there? And by abbreviating it, you obviously understand the nuts and bolts of what we're talking about here. That's why that's so much more important than just yes or no. I know you can guess yes or no. I know you can flip a coin. Okay? Do you know why, though? That's what we're trying to teach you. It's not just about getting the assignment done, it's about trying to understand the material. That's why the justify part here is so important. And if you don't know how to justify it, then you need help. And you need to ask for help. Or you need, and if you don't have help available right there, one of the best things you can do, go to this right here. Isn't this a kind of template on how to do your assignments? You could, if you go and look and you see, hey, that's what happened here, and then one you didn't know how to justify happens here, you're able to look at this and say, oh, wait a second, that's how you do that. And you learned something there. You probably learned more from me just telling you, because you kind of had to figure it out yourself. Number 2, can I justify that these are a parallelogram? Yes, you can. Why? Opposite angles are what? Isn't that enough information to justify it right there? Now, if you want to write out the whole, go get the theorem from the book and write the whole theorem out, fine. But I would like you to write this, and I really don't want you to put theorem 2 point whatever, because are you going to remember what theorem 2 point whatever was after this, after you go to sleep tonight? No. What I would rather you remember is that the opposite angles are what? In a parallelogram. Absolutely. This one here, is there enough information? Like I said, it seems like there's always two things. There's these two sets of things being congruent, or this one set of things being both what? Congruent and what? I just found out one thing here. That's never enough information. Because think about it, you could stretch this, you could bend these two towards each other, to be honest, and you could have yourself a trapezoid. A trapezoid, by definition, has these two being parallel to each other. An isosceles trapezoid, which we'll learn about later, has opposite sides congruent. That sure isn't a parallelogram, is it? No. So the answer is no. Why? Not enough what? Information. That's enough for me. How about here, number 4? Is there enough information? Yes. Why? Why are they opposite? And here, instead of saying angles, we'll say what? Sides are what? And you see how this is a great assignment for helping you remember those facts about a parallelogram. Before we get done with this chapter, you will have to know all the things that are true about a parallelogram, then all the things that are true about rectangles, rhombuses, and squares, which are all specific types of parallelograms. And then you're going to have to know all the things that are true about trapezoids and isosceles trapezoids. So you better start learning this now. It's easy to get it kind of mixed up when we start. We're going to make a little, in the next section, we'll make kind of a little flow chart of what's true about every one of these, to where you have it. Okay? Let's go down to number 8. These problems are in essence just like last section. So it's kind of more of the same. Braden, you need to be writing this down. Not working on the assignment. No, you need to be writing this down in your workbook. Now, all they're doing is just wording the problems. Yesterday they said the following is a parallelogram, find x and y, right? Here they're saying find x and y so that each quadrilateral is a what? So basically what they're saying is find x and y so that these would have to be a parallelogram. So all they're saying is, guess what? All 6 of those things are true. Find x and y. It's the exact same problem. It's just worded in a different way. Because if this is a parallelogram, then we know all those 7 things are true, correct? So here, what's going to be helpful here? Am I talking about sides or angles? Sides. So what fact would probably be helpful here? To know that what? In a parallelogram? What about the sides? Opposite sides are congruent. Doesn't that tell me 2 equations right there? One equation, 2y is equal to what? Y plus 9. Then also tells me the equation what?
2x minus 8
X plus 16. Oh, it's 19. Okay, thank you. These wouldn't be that hard, would it? Can you guys do this the rest of the way? Okay, let's set up this one. Because really, that's the geometry like we talked about Tuesday. That's the geometry in this problem. The rest is what? Algebra. We need to set up this equation. What is convenient to know here? Here it was that the opposite sides are congruent. Here we're talking about lengths of sides, but we're not talking about the sides. We're talking about the what? What are these two things called? Look at my pen. Diagonals. Which of our facts deal with diagonals? What does it say? Diagonals bisect each other, don't they? So what does that tell me? This is congruent to this, and this piece is congruent to this piece. So tell me an equation.
2y minus 7 equals 1 plus 3, and 4x minus 3 equals 3x.
Isn't it nice when it kind of starts making some sense, and it's really, you realize that the concept of what we're actually doing is pretty easy? Now, but you have to be able to, and this is what messes with people in geometry some, you know, when you're solving an equation, there's kind of one rule, you know, keep it balanced, you know, and get everything on one side, everything else on the other, right? You kind of do the same thing every time, just with different stuff. Here I have to realize I have a different situation. I have to be able to look at this situation and realize, why is this so much different than either one of these? Can anybody tell me? You can't just get set on the fact, hey, it looks like I just set things equal to each other all the time. You know what I mean? There's a reason why you did that. Here, this is completely different. Why? Because they're angles. What gives that away? I'll zoom in really, really close. What gives that away from your book?
The degree.
The degree sign. We measure angles in what? Degrees. So now we're talking about angles, so we're not going to talk about, still can talk about things being congruent, but we're talking about a different type of measure, and that is important that you understand that. Well, look for the keyword angles in our rules. What do we know about angles?
Opposite angles.
Opposite angles are congruent, are the same measure, so this one's congruent to this one, and this one's congruent to this one. But we also know that consecutive ones, the ones opposite are equal, and the ones right beside or on top of each other add to what? Now, and these are the ones that usually people struggle a little with, even though they're still pretty easy, is you have you have a bunch of possibilities to make equations here, don't you? You can either say they add to, these two added together equal 180, these two are equal, these two are equal, but a lot of times what do they put? They put an x and a y. One way may help you, one way may not. Which fact helps us the most here? The fact that the opposite angles are congruent. Why? Because it gets us the equation 4x minus 35 is equal to what? And what's the only type of variable in that? X's. Okay? I could have, if I wrote this plus this equals 180, that's a completely correct statement. The problem is, there's what? Both an x and a. It becomes much more difficult to solve that. I would first try to make sure, before you get two equations with two unknowns and solve systems of equations, I would make sure you don't have a way to write a valid equation with just one unknown. And what's the other equation I could write here?
2y minus 5 equals y plus 15.
And all of you can solve that equation, can't you? So let's go to this one. What is this problem exactly like? Number 8. I'm dealing with what? The sides, and I know that the opposite sides are. So your equation here is x plus 20 is equal to what? Or x minus 14. 3y plus 2 is equal to what? Y plus 20. And what I want you to guard against is it turns out in all our examples we did here, we ended up setting them equal to each other, didn't we? However, will that always be the case? No. Always just deal with what's in front of you. Unfortunately, the answer's on the back. They do the same thing if I did these on the back. But we need to realize that you're going to have to do some problems where this angle plus this angle equals what? Okay? And remember, if you have sides, sides don't equal 180. That's degrees, right? And I see people make that mistake. okay? All right, let's, I'll write down our assignment. I may make this a little different from Canvas. And this is due right now at the end of the hour tomorrow. But I'm considering starting a little bit of the next section tomorrow and doing it some, so don't count on the whole hour tomorrow. Because I personally think this is pretty easy, and if we put some effort forth, we should be able to complete this. Now we're going to stop right there, and there's really like I said, in some ways it's just redoing stuff we did yesterday. So we ought to do pretty well.